It is closed and there is no coffee. The machine works only with coins. So my productivity will be decreased in the next 50 minutes, seriously. Okay, so practice. Actually I start earlier, but I start because then we have more time to do exercises. Yes, where we are? We are here. This is a very similar to the previous stuff. The difference is that now I have the exercises. Last time, you had exercises in Hungarian, so I had to write on the board and translate. It was not perfect. So we had done this, which is a bit in medias res, but doesn't matter, at least we had done and you have homework from it. Next one is this one. So we finished the first the first four. First four. I can check actually. Where we are. The start of F. Yes, the 4, that was the last. Great. Okay. Great. So now we have English exercises. Metal surface is radiated, illuminated. Illumination means, well, it's something reaching the nirvana or something like this, but I don't know. Is illuminated by or radiated by light of wavelength 492 nanometers. The maximum kinetic energy of the emitted electrons is this one. When the wavelength of the light is changed to this, the kinetic energy decreases to this one. Based on these data, determine the Planck constant and the work function characteristic of the metal. Great. Yeah. Okay. See? I started earlier. Where did you take this, the candy, the water? If it is closed. I don't know the place. So where can I take coffee if that buffet is closed? So where did you take your candies and water? Okay. So it's something different. Doesn't matter, not important. Not physics. Okay, so now what I told you is that last time, I must apologize, last time you had Hungarian exercises. I translated them to English. That will be available on the Moodle and also on GitHub. And now we continue with the last two exercises. So, first thing, to understand what is the task. So you have a metal surface. You have a photon and one electron escapes. Yeah. Second, you have the same metal, you have a bit different photon, and the electron has a different escape. Kinetic energy. is the energy characteristic of the metal, but, well, we will see. So what we know? First of all, the first case, you have this 492 nanometers. It's something green light or something like this. The other, this 579 nanometers, is something yellow. So in the first case, the wavelength is shorter, the frequency is higher, and the energy of the photon is also higher. And what you can see is that in the first case, the electron, when it escapes, has higher energy than this one, than here. This is almost 20 times higher in that case. So this is good. Seems to be reasonable, this exercise, and more or less now we understand it, at least me. But I hope you also. No, not hope. I believe that. You know, Friedrich Gate said that the hope means the hope is the first sign of you are defeated, or something like this. Not perfect. So we have energy usually. We have frequency. We have the photon energy. That's this. No, it's better if. So we have the energy of the photon, and this will be some threshold from the metal, and the kinetic energy. This is the Planck constant times frequency, and this is from the metal, and also we have this out kinetic energy. We don't have frequency, we have wavelength. So we have we don't have mirrors. Okay, so this is the key equation. Everything that we know. We know the kinetic energy. We know the lambda, the wavelength, and the what is the name? The speed of light. Ow. We have Planck constant. We have speed of light. We have lambda 1. We have this mystic stuff of the metal. And we have the kinetic energy of the electron, and we have this twice. So, we have to determine this Em and the Planck constant. First, I subtract the second equation from the first one. So I will have something like this will disappear. Okay, we know lambda 1, lambda 2, we know the energies, we know the, what is the name, speed of light. So we can determine the Planck constant. R revolutionary RV. So H is
6.626 equal to 10 in the minus 30.
You have calculated already?
No, it is the Planck's constant. You use this. The constant like value.
Sorry,
You use the constant value.
we determine that constant value.
Yes, that H.
No. That's the exercise, the task.
We need to calculate this now.
Yes.
Not constant.
Yes. It's constant, but we don't know. We are revolutionary experimental physicists and we determine the Planck constant right now. It's okay, thank you. Okay, I forgot to do something. Nanometer is very nice, but we don't like it. Meter is our friend. The joule is fine, that's okay. I'm quite happy with the joule. So, let's see what we have here. Lot of mess. This is okay, let's see what we have. Okay, the unit, okay, I have private students, pupils, and one of them just told me he has never seen anyone who cooperate with the units. Well, I made a lot of mistakes, so I have some methods to check myself. Here we have Joule. There is meter per seconds per meter. So the unit of the result will be Joule seconds in the Planck constant. That's fine, that's okay. So this works. And this is not 6. Oh, okay. This is 0, so this is 20 minus 20. Let's see what we have. We have something that's quite interesting. This is very, very interesting. So this will be 9, 20, okay, interesting. So what we have, Joule second is the unit, and based on the numbers, it's something this is the order, because that's -9, that will be +9, and then divide, so it's okay. Oh, I forgot something. Yes, I forgot something. 20. Uh-oh. This is interesting. What was the value of the Planck constant? 6.62 and then 10 on the -34. Then something is not good, or I don't know, we will see. Is it? I have an idea what is wrong. Not this is wrong. So it's -9. Oh no, it's okay. -9, that's +9, 17. Okay, so this is not that one. Okay, it's better. So let's see what we have. Minecraft launcher. better. Not perfect, but much better. That's R Planck constant. Of course, it's not that one that is in the books because we have these numbers. So perhaps it's wrong, and actually always it's difficult to determine these values. Funny. Seems to be this calculation good. So we have the Planck constant, and now we need this metal energy characteristic. No. We know the Planck constant, we know the speed of light, we know the wavelength, we know the kinetic energy. So we can do it easily or not. Okay, so we have everything that we need. So this A is nothing more than okay, so this Ah, great. Okay, so it means funny. So this is the energy that's necessary to read the metal. Well, these are weird numbers. We have 20 minutes. So we can do the following. This is ready. Okay. However, there is an alternative method. The other energy and wavelength. got the same number, but it's different with the order of magnitude. Yes. Yes, because that's wrong. It's minus 27, and then it's minus. Okay, great. So we got the same. Here, there's a miscalculation. Here, this is the end of the task. This is just a check. It's not necessary to do, just I was not sure that I am right. Do you understand what we have done? It's the same. So we have photon, we have threshold in the metal, and then we can calculate the kinetic energy. It's the same. Just here we had two equations, and we determined the Planck number and this one. Actually, this Planck number is not good. It's not what is in the reality, but perhaps the numbers are not good. But we calculated well because the result for the metal is good. There is also something that's common. The sound. Okay, so we have enough time for a Cooper test, or fix this last stuff. When light of a certain frequency when a matter surface is radiated by a certain frequency of light, the measured stopping potential of the emitted electrons is 3.9 volts. For light of half of the frequency, the stopping potential is 0.625 volt. Determine the work function and the wavelength of the light. Interesting. Okay, so these exercises are heritage. This is my first semester when I teach this subject, so I used the ancestors, the previous tutors or professors' material, and sometimes it's funny. For example, now, this exercise is the same like the previous one. The only difference is the following. In the previous one, this one, 5, we use joule. Here, they are not so, they don't, this exercise doesn't show mercy. We have to use electrovolts. At least at the beginning, so I will change everything to joule very soon. Okay. Yeah. I have an empty. Board. Now so we like at a certain frequency this metal stuff, I mean surface. We have electrons to hit out or escaping with certain energy. Then it's the same actually. We have same exercise. We have light with another frequency and frequency. Yeah, but we don't know this frequency. And then the electrons are leaving, and we have another Yes, so it has some potential to keep them here. And these are different. So what we have? We have we need the wavelength. And the stopping function, I mean, this is the energy. Metal. I not really understand this question. Huh. Yes. That's interesting. Okay, this is the okay. So that's it. This is what I mean. This potential is necessary to stop the electrons which are escaping. It's easy to determine the energy. It's not that, but the or no, not W. That's multiplying these numbers with by the charge of the electron. And then oh, really? Yes. So we have these energies, we are happy, and what we know, this is the same. So we have an energy of the photon, and this will become something like this. And we have some work on the metal. This one means C lambda. This one means. Okay, so we have this formula, and we have two equations: H C lambda 1 H C lambda 2 the area is the same. We don't have nails anymore, doesn't matter. Escaping. Okay, so it's not good. We have Planck, we have it will not work. will not work. Okay, this is true, just it's perfectly useless. We have the kinetic energy, that's fine. We have the Istenem, something important is missing. For light of half that frequency, something was missing was okay. So this is half of the frequency is a double of the what is the name? The wavelength. So half frequency double wavelength. This is just a moment. So this is half of the frequency. Frequency double wavelength. So it means something is wrong here. Yes, that's wrong. That's okay. Okay, so sorry, 10 minutes extra, apologize. You can finish this at home. We have the lambda 1, and from the lambda 1 we can determine the lambda 2, and also we can determine the energy that necessary to leave the metal. Okay, thank you very much. See you next week. válaszokat, és akkor utána azt fog történni, hogy szerintem adom a KTXFI.
Tehát akkor az első erre kötelező.
Igen, és akkor a második az extra. Az nem, arra ezt a pontot jönnek. Igen. Most lehet, hogy előbb megcsinálom, tehát én meglehetősen sok mindent csinálom, és utána 4 állásom van. Így alakult, úgyhogy ez már olyan jól fizetnek mindenütt. Illetve egy helyen jól fizetnek, csak az csak októbertől van. Tehát valahogy majd meg fogom csinálni, az elég bajom. Nem tudom, mit adtak önöknek. Most egyelőre ez itt most relativisztikus izével, meg a Comptonnal, meg ezekkel most le fogjuk venni szépen ezt az órát, meg a következőt. Most egyébként fel fogom adni a másodikat majd körülbelül magamnak, de hogy ebből a Fermi-Diract akármiből mit adja, azt mindent tudom.
Jó, de akkor a negyedik meg az ötödik, az plusz pont,
az plusz.
Egyben
lesz mind a kettő. Tehát úgy néz ki a dolog, hogy egy van a kettőre, mármint ugye a végség ez egy lesz, tehát kapnak egy ZH pontot, meg kapnak egy vizsgapontot, és akkor azt még meg lehet dobni ezzel a kettővel.
Okay.
Mert ugye még egy izé van, azt a jövőre nem fogom most már nem fogom megváltozni, jövőre nem lesz, hogy 40%-ot el kell jönni az ajánlásra. A felét nem tudom a végségesért.
Jó, rendben, köszönöm szépen.
Oké, viszontlátás. Igen?
Úgy fog kinézni, mint tavaly?
Köszönöm?
Úgy fog kinézni körülbelül, mint tavaly, sok a
micsoda?
vizsga.
Fogalmam sincs.
Sokat talán.
Ugyanis én október 1-től vagyok itt, fogalmam sincs, hogy jött a vizsga tavaly.
Most én közben csak elmélet volt.
Tehát lesz egy, nekem én úgy gondolom, azt elmondtam az elején, hogy lesz egy ZH, ott feladatot adnak meg, mindent használnak, egymással meg eredetnek eszközben kívül. Ezt a számolók ilyen nem lesznek, hogy kitalálom, hogy csinálni. Zavarom a wifi, nem tudom, valahol kitalálom. A vizsgának meg elméleti kérdések lesznek, nem fogok kérdezni feladatokat. Tehát, vagy ha van valami, akkor az elméleti feladat. Rákérdezik fogalmakra, meg hosszabb folyamatokat elején. Mit tudom, még írja le az atomoknak a elektroszerkezetét, és mi van közel a periódikus rendszernek az elemekhez. És akkor erről írnak nem tudom egy oldalt, akkor ha van valami közel ahhoz, amit rámondnak, hogy nem boldog leszek, megvan a maximum.
És akkor ehhez mondjuk ez a kérdés, ezt tudod, hogy akkor kéne a boldog, a radar, a atomodell, és akkor azt tudja elmagyarázni, hogy ez milyen kérdés, és milyen 3 dimenzióban van.
Igen. Tehát ezt vissza. Vagy, hogy mik ezek a PIN, meg ezek az szennyezések, ez miért világos. Egyébként csodálkozom, és más szállót használom, csak földolgozom, meg elfogadani angolra, hogy például nem beszélünk benne a diódónak a tranzisztor. Ezt bele fogom rakni, mert van visszafelé Pécsre. Tehát, hogy ez az értelme. De ez egésznek mi az értelme? A tárgynak. Most akkor nem tanultak már tranzisztorokról?
Sajnos.
Tehát van elektromagnetem, és ott írva törvények meg a társak. Olyanok voltak az alap.
Igen.
És akkor utána volt ilyen...
Utána belevettünk külön a félvezetőkbe egy másik tárgyon belül.
És a félvezetőkről mit tanultak?
A felépítésüket, a karakterisztikát, alkalmazásokat.
Ilyen kicsi elméletet, hogy a tanárból magyaráztál, hogy akkor írjuk vannak benne, és akkor az elektron átfér egyik irányba.
Ezt én magyarázom így, vagy az, aki azt a tárgyat hallgatta?
Horváth már.
És akkor ő ugyanezt mondta, ezeket a közölőket.
Igen.
Jó, oké. Ezen a lényeg egyébként, tehát ez a lyuknak hogy működik. Majd egyszer valamelyik ők csinál egy kérdezem, hogy csinálnak 10 évességeket Magyarországon. Jó lenne. Nem?
Jó lenne.
70%-ot az testalajban van. Nem szeretett az országot, nem sokan. Minket is szeretnénk. Még valamit? Kérdés? Jaj, basszus! Nem kapcsoltam ki a izét a... Menjenek nyugodtan, csak nem kapcsoltam ki, viszlát!